All right, so far we've been graphing quadratic functions given an equation. Now we're going to start going the other way around. We're going to have a graph or some given information about the quadratic function, and we're going to write an equation from that information. So let's take a look at our first example here. We're going to write the quadratic function for the parabola that's shown. So since they have given us the vertex and another point, it makes sense for us to use the vertex form. Now the vertex form, we've been using it, although we haven't actually formally said what the formula was, but that's y equals a times x minus h squared plus k. And we've been using it because our vertex shows up there in h and k. So now instead of using it to graph, I'm going to take that information from the graph and put it into the equation. So for this particular one, the vertex is at 1, negative 2. So y would equal a times x minus 1 squared minus 2. Because you can see if I plug in a 1 for x, 1 minus 1 is 0 squared. Remember, we want what's in the parentheses to equal 0. And so that's going to work. So now I just have to figure out whether or not the graph is being stretched or compressed, whether a is 1 or if a is another number. So to do that, I'm going to use the second point that they gave me. And where the x is, I'm going to put a 3, and where the y is, I'm going to put a 2. So 2 equals a times 3 minus 1 squared minus 2. And then I simplify it. 3 minus 1 is 2, so 2 squared. And then 2 squared is 4, so I have 4a minus 2. And then adding 2 to both sides, I get 4 is equal to 4a, and so that means that a has to equal 1. So my equation is y equals 1 times x minus 1 squared minus 2. So do I need to have that 1 that's out in front of the parentheses? No, it's assumed to be there, so we can get rid of that. We don't have to have it there. All right, so now I'm going to give you guys a problem to do. On your whiteboards or in your notes, the vertex is at negative 3, 1, and the point that it's going to go through is 0, negative 8. So go ahead and give this problem a try. Alright, so we should be starting with y equals a times the quantity x plus 3 squared plus 1. And then you would plug in your x and y. X is 0, y is negative 8. So negative 8 equals a times 0 plus 3 squared plus 1. And so 0 plus 3 is just 3. And if I square that 3, I get 9a plus 1. And so then we subtract the 1 from both sides. Negative 9 is equal to 9a. So in this case, a would be equal to negative 1. So my final equation would be y equals negative of x plus 3 squared plus 1. Another form that we might use is our intercept form. Here I have a graph with the two x-intercepts and another point on the parabola. And so I'm going to use intercept form for this one. So again, I'm going to have a factor, if it's being stretched or compressed, of a, and then I'm going to have my x-intercepts in the parentheses. So if my x-intercept is negative 1, that means that when I put a negative 1 plus something, it's going to have to equal 0. So what's it going to have to be? It's going to have to be a positive 1. And then same thing here, if I put in the 4 plus something, I want it to come out to 0, that means this is minus 4. So I've got a times x plus 1 times x minus 4. Now I'm going to plug in the 3 for my x, and the 2 for my y, and solve for a. So 3 plus 1 is 4, 3 minus 4 is negative 1, and I get the 2 is equal to negative 4a. And so when I divide by negative 4, I get that a is equal to negative 1/2. So my equation would be y equals negative 1/2 times x plus 1 times x minus 4. All right, here's another problem you can try on your own. All right, so this is our starting point. Y equals a times x plus 2 times x minus 5. And then if I plug in the 6 and the 2, 2 for y, 6 for x, I get 2 is equal to a times 8 times 1. So basically 8a is equal to 2. I divide by 8. And a is equal to 1/4. So my equation would be y equals 1/4 times x plus 2 times x minus 5. All right. Now for example 3, I'm just given 3 random points on the parabola. We're going to write the quadratic function in standard form for the parabola that goes through the points negative 1, 3, 0, negative 4, and 2, 6. So first of all, I need to have my standard form for a parabola. So ax squared plus bx plus c is equal to y. And I'm going to plug each of those points in and get a new equation. So for negative 1, negative 3, I put in a negative 1 for x, and I put in the negative 3 for y. So when I simplify that, negative 1 squared is positive 1, so I have a minus b plus c equals negative 3. Now I'm going to do the same with the point 0, negative 4. A times 0 squared plus b times 0 plus c equals negative 4. So in this case we got lucky, everything cancels out except for the c. We have that c is equal to negative 4. And then finally I'm going to plug in the point 2, 6. So a times 2 squared plus b times 2 plus c is equal to y, which is 6. And so that's 4a plus 2b plus c is equal to 6. So now I have a system of 3 equations in 3 variables. And I can solve for a and b and c. Well, c I already know, and so what I'm going to do with c is I am going to put it into these 2 equations so I can get 2 new equations with just 2 variables. So if I put it into the top one there, I get a minus b plus negative 4 equals negative 3. So if we add the 4 to both sides, I get a minus b is equal to 1. And then I'm going to put it into the 4a plus 2b equation. So 4a plus 2b plus negative 4 is equal to 6. So when I add the 4 to both sides, I get 4a plus 2b is equal to 10. So now I have a new set of equations with 2 variables, 2 equations. I can use elimination to solve these. So if I want to make my b's go away, I'm going to multiply the top equation by 2, and I'm going to get 2a minus 2b equals 2, and then I'll write my other one under it. 4a plus 2b equals 10. I get 6a, and then my b's cancel out, is equal to 12, and so I know a is equal to 2. Now I can go back, I can take this a and plug it back into either one of these equations. I'm going to choose the one with the smaller numbers. And so when I do that, I get that 2 minus b is equal to 1. So 2 minus 1 equals 1. So b has to be 1. Now that I have all three, I can just plug that back into my standard form. So again, the standard form was y equals ax squared plus bx plus c. I'll worry about that right now. So when I plug in my a, b, and c, I get that y is equal to 2x squared plus 1x, so that's just x, minus 4. And that is the final answer. All right, and so just one more example of that. Here, I've got the points negative 1, 5, 0, negative 1, and 2, 11. Actually, let's do this other one instead. Let's do one where it's a little bit more complicated, because I want to make sure you have a chance to see this as well. All right, so let's do this one. We've got negative 1, 0, 1, negative 2, and 2, negative 15. So plug each of those into ax squared plus bx plus c equals y, and get your system of 3 equations. Okay, so after you plug those in, you should have ended up with your system of 3 equations. A minus b plus c equals 0, a plus b plus c equals negative 2, and 4a plus 2b plus c equals negative 15. So it looks like the b's are going to be pretty easy to get rid of. So I'm going to combine the first two together, the a minus b plus c equals 0, and a plus b plus c equals negative 2. So if I add those together, I get 2a, the b's cancel out, plus 2c is equal to negative 2. Next, I'm going to get rid of b using this last one. So I see I have a 2b on the bottom. So I'm going to multiply the first one by negative 2. So when I do that, I get negative 2a plus, oops, not negative 2. Let's make that positive 2. Okay. Negative, so 2a minus 2b plus c equals 0. So now when I add these two together, I get 6a plus 2c is equal to negative 15. So since I have 2a plus 2c, I can multiply this equation here just by negative 1. So negative 2a minus 2c equals a positive 2. And then my c's cancel out, and I have 4c is equal to negative 13. That's not a very pretty number. Okay, I just realized I made a mistake here. So when I multiply by 2, I forgot to multiply the c by 2 as well. So that's where I went wrong. Okay, so let me combine those again and get a new set of equations. 4a and 2a, I get 6a. The b's cancel out, and I get 3c. is equal to negative 15. Okay, so now what I'd like to do instead, I think, is I'm going to divide this one by 3. Everything divided by 3. And then I get 2a plus c is equal to negative 5. And then I will go ahead and subtract the other one, minus 2a minus 2c equals positive 2. And so I have negative c is equal to negative 3, and so c is equal to positive 3. Alright, and so then I can use any one of the equations. I'll just go over here to this one. 2a plus 2 times 3 is equal to negative 2. And so 2a plus 6 equals negative 2. If I subtract the 6, 2a is equal to negative 8, and so a equals negative 4. So now I have got c and a, but I still need to figure out b. So I can just go back to one of my original equations, and so the one that I see up in there in blue, I can use that one. A, negative 4, plus b, which I don't know yet, plus c, which is 3, has to equal negative 2. So that's b minus 1 equals negative 2. If I add the 1, b has to equal negative 1. So now I have all 3 of them. My final equation, y equals negative 4x squared minus x plus 3.